Alright, let's look at the gamma function. And one of the properties of gamma function is gamma of 1/2 is magically square root of pi. Alright, so let's try to prove that. Alright, so by definition, gamma of 1/2 is integral from 0 to infinity e to the negative t times t to the 1/2 minus 1, so it's going to be negative 1/2, right? And dt, right? And I'm going to do a little bit of substitution here. I'm going to let t to be x squared, right? Then you can see that by taking a derivative of t with respect to x, we're going to get 2x. So by multiplying both sides by dx, we get the expression for dt. dt is equivalent to 2x dx, right? Then we can also do the lower bound and upper bound. So originally, t is going from 0 to infinity, and the corresponding x is going to be, when t is 0, x is going to be 0, and when t is infinity, and the square root of infinity is still infinity, so x is going to infinity, right? So we can rewrite this integral as integral still from 0 to infinity. We have e to the negative, t is now x squared, right? And then you have x squared. Then you want to raise that to 1/2 power, right? Then dt is 2x dx, right? Then you can see that here, if you take the raise it to the 1/2 power of x squared, so this is going to be simply x to the negative 1 power, because 2 cancels out, so it's going to be 1 over x, right? But luckily we have x right here, and you have a 1 over x, they cancel out, and I can probably bring 2 outside the integral, right? So we end up getting, I'm going to go down here, right? I'm going to end up getting 2 times integral from 0 to infinity, right? And then we have e to the negative x squared dx, right? So we need to evaluate this integral. So I'm going to call this guy, this integral right here, let's call this guy I, so we can find I. Alright, so let's try to find I. So I is going to be equal to, actually I'm going to square this. I squared is equal to, alright, so I'm going to have to multiply, I is the integral from 0 to infinity, e to the negative x squared dx, right? I'm going to actually write the same thing, except that I'm going to use a different letter, but since x is a dummy variable, we can use any letter we want. So I'm going to use actually y, from 0 to y, infinity, e to the negative y squared dy, right? So we have that. Alright, so this is actually, x and y are independent of each other. We can actually put them together as a double integral. So it's a double integral from 0 to infinity and 0 to infinity. Then you can put them together, so you have e to the negative x squared minus y squared, right? dx dy, right? Then I'm going to use the polar coordinate to rewrite this integral. Alright, so this region, if you sketch the region, it's going to look like this. Alright, this is actually a first quadrant, right? Because x is going from 0 to infinity. y is going from 0 to infinity. So we are talking about this region right here, right? Right, first quadrant. So if you want to do a first quadrant in polar coordinate, it's going to be, right, so r is going to go from 0 to infinity, obviously, and the theta is going to go from, remember that the theta here is 0, right, so r is going to go from, say, 0 to infinity, so r goes to infinity, right, and the theta starts from here, then go all the way around, not all the way around, sorry, and go to up to theta equals pi over 2. So we know that it goes from 0 to pi over 2, right? Then in polar coordinates, you have e to the, e to the x squared plus y squared is r squared, negative r squared. Then you have r, dr, d theta. Alright. Alright, so this is separable. I'm just gonna separate it into integral from 0 to infinity, right? E to the negative r squared times r, dr, times integral from 0 to pi over 2 and d theta. Right? So let's evaluate this part. So I'm gonna do, let's see. Right, I'm gonna do a substitution here again. I'm gonna let u is equal to, let's say, negative r squared. Right? And if you take the derivative of u with respect to r, we get negative 2r. Then, since we're looking for dr, so I'm going to take the reciprocal of both sides. So dr over du is equal to 1 over negative 2r. Then multiply through by du so that we have an expression for dr. dr is equivalent to du over negative 2r. Alright, then in this case, so let's say r is going from 0 to infinity, and then u is going from, you have a 0, still 0, and 2, negative infinity squared is negative infinity. Alright, so we're going from 0 to negative infinity. Right, you have a e to the u, right, r is r, dr is du over negative 2r. Right, then here, this one's easy, antiderivative 1 with respect to theta is theta, going from 0 to pi over 2. Right, so we can cancel r on top and r on the bottom, and then I will bring out the negative. Actually, I'm going to actually use this negative sign to switch this upper limit and the lower limit. We can do that, right? So we end up getting, so there's a 1/2, that's just a number, right? Antiderivative e to the u is e to the u. And then we're going from negative infinity to 0, right? This one you plug in pi over 2 minus 0, so you just get that. Alright, so what you get is going to be, alright, so pi over 2 times 1/2 is pi over 4, times plug in 0 is going to be 1, minus plug in negative infinity, e to the negative infinity is 0, so we know that this is just going to be pi over 4. Alright, so I squared came out to be pi over 4 by taking the square root of that. So if you take the square root of that, we get the I, which is square root of pi over 2. Alright, so we're going to put that back in. So it's going to be 2 from here. But this integral I came out to be square root of pi over 2. So we can cancel 2 on top and 2 on the bottom. And we end up with square root of pi. Right? So that verifies this equation. Gamma of 1/2 is equal to square root of pi. All right, that's it. I hope that this was clear.